Chapter 1 Intro. One of the oldest materials ever made by human hands. Glass. And yet the process used to make it today is one of the most precise, most automated, and most continuous manufacturing operations in existence. This is how 1 billion glass bottles are made every year. It starts with 3 humble raw materials. Silica sand, the primary glass-forming ingredient. Soda ash, which lowers the melting temperature. Limestone, which gives the glass stability and durability, mixed together with crushed recycled glass called pellet. These ingredients form the batch that feeds the furnace. Every ingredient is weighed automatically to the kilogram. The batch is mixed to a precise, homogeneous blend and conveyed directly to the furnace charging system. The process of making glass begins at the furnace doghouse, and what happens next is remarkable. Chapter 2 Intro. The glass melting furnace is an industrial marvel. It weighs over 2,000 tons, runs at 1,550 degrees Celsius, and it never stops. A modern glass furnace runs continuously for 12 to 15 years before it requires a cold repair. Inside, gas burners sweep flames across the surface of the molten glass. The batch dissolves, melts, and refines into a clear, homogeneous liquid. The glass flows from the melting zone through a submerged throat into the working end, where it is conditioned to the precise temperature needed for forming. From the working end, molten glass flows through 4 hearth channels to the forming machines. The temperature must be precise to within 2 degrees. Too hot and the glass is too fluid, too cold, and it won't form correctly. Glass making is as much science as it is fire. Chapter 3 Intro. The IS machine, individual section machine, was invented in 1925, and it is still the heart of container glass production. Each section of the machine takes a precisely measured gob of molten glass and forms it into a finished bottle in under 10 seconds. A rotating spout feeds molten glass into the feeder, where shear blades cut precisely sized gobs that fall by gravity into the IS machine sections below. In the blank mold, the gob is pressed into a parison shape. In the blow mold, compressed air inflates the parison to the exact shape of the finished bottle. A 12-section IS machine running on double gob operation can produce over 500 bottles per minute. Every bottle identical, every cycle timed to the millisecond. The hot bottles emerge glowing orange red, placed upright on a conveyor heading for the annealing layer.
Aisle 3 is clear. Move the bottles to upper racking.
Bay 2 is secured.